Alright, so I'm going to do a kind of recording of how to get through CLC, which is on Hummingbird. So this is what the window, when you just open the program, what it looks like. What you have to do is, I guess you can't see my top menu, but you go to File, Server Login. Log into the server. You want to run all these big jobs on the server. We'll have to get confirmation of what the username and password is, but I think the username is fish546, but everything else is the same. You hit login. Then you have these two drives with blue dots. That means you're actually running the jobs on the server. So what I'll do is I will shift. First thing you would have to do is import data. So you want to make sure you import it on the server. Where is it? It's in my local space. Let's see what kind of. I'm going to select some paired in data. So that's 106A R1. I know that's the same on R2. I want to say paired reads and discard read names. Hit next. I'm going to save it in this directory, and now it's uploading. This will take a while, but we'll go ahead and show you what it looks like once it's uploaded. Go to here. Again. This is what one of those files would look like. This particular one is same data. It's about 80 million reads. You can kind of see the quality scores here. We want to do and show you how to do an RNA-seq. So these, as we mentioned in class, we just want to map these back to a backbone or a scaffold or a transcriptome and do the counts of reads. So I want to import the transcriptome. Alright, so what I'll do is I'll just import it here. Now I'm just doing a regular import because it's not next-gen data. It's just a regular FASTA file. There's version 3 of the transcriptome. Select automatic. It seems to be high throughput data. It's just a lot of FASTAs. Skip this? No, I don't want to skip it. I don't make mistakes. This is not high throughput. Take a while to get through. Okay, so I ended up importing this version 2 of the transcriptome. So this is what it would look like. I think you can actually zoom in and actually see the sequences. Some issues with version 3, but this will work. So to do RNA-seq, you can just simply select the reads. We want to make sure you run this on CLC server, RNA-seq analysis. I guess in theory we could combine them, but we'll just do one library. We want to symbol it to a reference without annotations. That's going to be this version 2. This is the length of the fraction that has to match, and the maximum number of hits for a read. If a read hits more than 10 spaces, then it will not be used in the data. That's just if you had a genome. We'll create a report and we'll hit save. Just not to confuse, and I'll put this in the temp folder. Okay, so then now it's starting an RNA-seq job on a node. I'll go ahead and do another one here. That's the advantage of using the server is you can handle multiple jobs. Alright, so it's got 2 nodes, so it'll finish. Once he's finished jobs, this job will start. And I'll show you what that looks like a little bit later on. Okay, for the sake of just getting done with this and posting this video, this is what it would look like. This is happens to be another RNA-seq data set, but same species. But the point being, you get a table that looks just like this, and these would be, when we're talking about DE-seq and these other programs, you would feed it in with these read counts, and we can discuss the value of doing unique versus total. But you really, from my experience, you're going to get about the same, and as you see here, they're quite similar. So that's it. That's how you would, in TLC, easily go from raw data into a table which has reads counts that you can put into one of these statistical programs to look for differential expression.